Korkut, that was a fantastic session, and I'm not sure by the end of it we know where we stand. Is it global warming, ice age? What do you think?
Well, I think oxygenated perfusion is going to help tremendously. The rest we'll figure out as we go along.
I mean, I really liked your idea of supercooling the organ because it opens a whole new range of possibilities. How did you come up with the idea?
Well, it was a group effort. We first thought about freezing the organ and then rewarming it because perfusion was so miraculous. That was horrible. The liver looked like it was nuked. So we played around with a few other things, and it was really a group idea that wanted to try this, and it just turned out that it worked.
What do you think were the main challenges is it the technology, is it the application? I mean, it's a great combination of medicine and biotechnology and bioengineering, and I think that's the future. But what were the main challenges for your specific project?
Well, the first difficulty is actually having both the medical and the transplant expertise and the engineering and applied thermodynamics expertise in the same lab. That is not a common combination. In terms of getting the application, the problem is the design space is so huge. There are so many things you can try, and you obviously have all the time and ability to try it so many times. So you have to get a little bit lucky too, and you really have to keep working hard at it. And Tim Berenson really did that and made it work.
You talked about 72 hours, which is great because all of a sudden you can cover the globe in 72 hours. If you are to look forward, how long do you think realistically we can achieve supercooling for?
So we are now working with two very accomplished cryobiologists that were actually behind the development of the ORS system as well. And we think we can push it to about a week or so, relatively in a straightforward fashion. There are a number of ideas we did not try, actually actively performing metabolic suppression to add on top of temperature. As well as to push the temperature even further by adding non-toxic antifreeze agents, so we can actually do that in a stable fashion. So I think we have still some leeway.
I mean, a lot of the approaches we've discussed today clearly look at how you manage the temperature regulation, and I think my personal view is that we should do a smooth curve in and out, and that's what you tend to suggest in your experiments as well. How do you deal with in your experiment, in your experience with the rewarming from -6 to nomothermia?
At the moment it's smooth. That's what worked for us for the most part. The gradient or the rate of change can actually be important. You can't do too fast or the supercooled organ will freeze and so forth. But there are also specific instances there where warming directly, although you will think it's a shock, actually works better. So again, these things are very complicated biological phenomena. You usually have to try and find out for yourself.
Okay. And we looked at this conference, there's a lot of options in terms of reconditioning organs, decellularizing scaffolds, etc. When all of a sudden, to me, it seems that your biobank that you're talking about as a potential storage facility, all of a sudden you can look at decellularized organ, recellularize them and freeze them. Do you see that working? Or what will be the challenges of that?
That's actually the long-term vision. You captured it perfectly. To have a centralized facility to get all the donor grafts, look at them. If they are quantitatively good enough to transplant, send it to where the ideal recipient is. If they are only so far so good but not perfect, we actually want to isolate the cells out of it and use those for either research or cell transplantation studies, which is another interesting field. And even if the cells are dead, then we want to decellularize them and use them as scaffolds for tissue engineering, which is the long-term, hopefully organs off-the-shelf solution to organ failure.
And what cells do you think we should use for repopulating those livers that would withstand your very low temperature?
Oh, I think the supercooling part will not be difficult. The difficulty is actually repopulating the grafts in a robust fashion that they work again in vivo. And I honestly don't know the answer. We may need to go with something that's a little bit immature cell that eventually develops and matures in the organ itself. Or maybe we'll be lucky enough and the primary cells will do their job.
But do you have enough evidence to say that those immature or premature cells would sustain cooling to that degree?
I don't, but I know at least one work that tried to do embryonic stem cell preservation, and they sort of had an intermediate supercooling phase. But no, that's not perfect evidence that shows that it actually works.
And the final question for me is, obviously you're talking about a biobank, which is an exciting opportunity, but also brings into the real realm of difficult ethical scenarios. Is who should control the biobank and who should get the organs?
You are trying to get me into politics as well as legal issues. That's a perfect question to ask. I do not know the best answer to that. I think something about the regional organ banks will be beneficial to everyone. Who controls or who decides is a very good question to ask.
Thank you very much. That was a fantastic session and I really enjoyed our talk. Thank you.
Thanks for having me.